Why do some aircraft have fixed landing gear while others retract their wheels after takeoff? The answer comes down to one important factor: drag. As aircraft speed increases, exposed landing gear creates significant parasite drag. At a certain speed, the drag penalty becomes greater than the extra weight of a retractable landing gear system. That is why many aircraft, from small general aviation airplanes to large airliners, use retractable landing gear. In this video, we'll explore how small aircraft and large aircraft landing gear retraction systems work, including hydraulic systems, sequence valves, uplocks, and emergency extension systems. Some early and lightweight aircraft use simple mechanical landing gear systems. In these aircraft, the pilot operates a lever connected directly to the landing gear through mechanical linkages. By moving the lever, the pilot physically retracts or extends the gear. To reduce the force required, manufacturers often use roller chains, sprockets, and hand cranks. These systems are simple, lightweight, and reliable. Some small aircraft use electrically operated landing gear systems. An electric motor, combined with a gear reduction mechanism, moves the landing gear. The rotary motion of the motor is converted into linear motion to extend or retract the gear. Because electric motors have limited power, these systems are typically used only on relatively lightweight landing gear assemblies found on smaller aircraft. A more common design in aircraft such as mini Cessna and Piper models is the Electro-Hydraulic retraction system, also known as a power pack system. The hydraulic power pack is a compact unit that contains several major hydraulic components, including a hydraulic reservoir, a reversible electric motor-driven pump, filters, pressure control valves, a thermal relief valve, and a shuttle valve. Some systems even include an emergency hand pump. Hydraulic actuators installed on each landing gear use hydraulic pressure from the power pack to extend or retract the gear. When the pilot selects the gear down position, an electrical switch activates the electric motor in the hydraulic power pack. The motor rotates the hydraulic pump in the direction that sends fluid to the gear down side of the actuating cylinders. Pressure from the pump shifts the shuttle valve, allowing hydraulic fluid to flow to all three landing gear actuators. Because the nose gear is lighter, restrictors are often installed in the nose gear actuator ports to slow its movement and prevent excessive impact loads. As hydraulic fluid extends the landing gear, fluid from the opposite side of the actuators returns to the reservoir through the gear-up check valve. When all landing gear reach the down and locked position, hydraulic pressure increases in the system. A low-pressure control valve opens and returns fluid to the reservoir, while limit switches shut off the electric motor. To retract the landing gear, the pilot moves the selector handle to the gear-up position. The electric motor now rotates the hydraulic pump in the opposite direction, sending hydraulic fluid to the gear-up side of the actuators. As the actuators begin to move, the landing gear downlocks are mechanically released. Fluid from the gear down side of the actuators flows back to the reservoir through the shuttle valve. Once the gear is fully retracted, system pressure rises and activates a pressure switch that shuts off the electric motor. The landing gear remains retracted using hydraulic pressure. If pressure decreases, the pressure switch automatically restarts the pump to restore pressure. Large aircraft almost always use hydraulic landing gear systems. Hydraulic pumps are commonly driven by the aircraft engines, although auxiliary electric hydraulic pumps are also frequently installed. These systems include hydraulic actuators, selector valves, uplocks, downlocks, sequence valves, orifice check valves, and extensive hydraulic tubing. All of these components work together to ensure the landing gear and landing gear doors operate in the correct sequence. Landing gear doors are extremely important on large aircraft because they reduce aerodynamic drag by covering the wheel wells. Different aircraft use different door arrangements. Some aircraft close the doors after the gear extends, while others attach the doors directly to the landing gear so the doors move with the gear itself. The timing of these door movements must be carefully controlled. When the gear-up position is selected, the landing gear retraction sequence begins. This positions the selector valve and directs hydraulic pressure from the aircraft's hydraulic system to the landing gear retraction system. Hydraulic pressure releases the landing gear downlocks, and supplies fluid to the gear-up side of the actuator cylinders. As the actuators move, the landing gear retracts into the wheel wells. During retraction, sequence valves keep the gear doors open by temporarily blocking fluid flow to the door actuators. At the same time, hydraulic fluid from the opposite side of the actuators returns to the hydraulic system through check valves. Once the landing gear is fully retracted, the actuator cylinders contact the sequence valve plungers, opening the valves and allowing hydraulic fluid to reach the door actuators. The landing gear doors then close, sealing the wheel wells and restoring the aircraft's aerodynamic profile. With the landing gear fully stowed and the doors closed, the retraction cycle is complete. When the pilot selects gear down, hydraulic pressure is directed from the hydraulic manifold to the landing gear extension system. First, hydraulic pressure unlocks the nose gear uplock. Fluid is then directed to the gear down side of the nose gear actuator, extending the nose gear. At the same time, hydraulic fluid flows to the main gear door actuators, causing the landing gear doors to open. As the doors open, sequence valves prevent hydraulic pressure from reaching the main gear uplocks and actuators. This ensures the main landing gear remains secured until the doors are fully open. Once the doors reach the fully open position, the door actuators engage the sequence valve plungers, opening the valves. Hydraulic pressure is then applied to the main gear uplocks, releasing them, while fluid flows to the gear down side of the main gear actuators. The main landing gear extends downward into position. Fluid from the opposite side of the actuators returns to the hydraulic system through restricted orifice check valves. These restrictors slow the extension rate and help prevent impact damage. When all landing gear reach the down and lock position, the extension cycle is complete and the aircraft is ready for landing. If the normal landing gear system fails, aircraft are equipped with emergency extension systems. These systems vary widely depending on aircraft size and design. Many aircraft use a gravity free-fall system for emergency gear extension. In these systems, an emergency release handle in the flight deck is mechanically connected to the landing gear uplocks. When the pilot operates the handle, the uplocks release, allowing the landing gear to fall into position under the force of gravity. As the aircraft moves through the air, aerodynamic airflow helps push the gear downward and assists the locking mechanism into the down and lock position. Some aircraft use alternative backup methods, such as pneumatic systems, to release the uplocks if mechanical linkage systems are not installed. Many small aircraft equipped with electro-hydraulic landing gear systems use a free-fall valve for emergency extension. When activated from the cockpit, the free-fall valve bypasses the hydraulic power pack and allows hydraulic fluid to move freely between both sides of the actuators. This releases the hydraulic pressure holding the landing gear in the retracted position. Once pressure is relieved, the landing gear extends under its own weight, while airflow over the aircraft helps move the gear into the fully locked position. This system is commonly found on light retractable gear aircraft because it is simple, lightweight, and highly reliable. Large and high-performance aircraft are usually equipped with multiple hydraulic systems. If one hydraulic source fails, another system can often be selected to operate the landing gear normally. Because of this redundancy, emergency extension systems are used less frequently on large aircraft. However, if all normal hydraulic sources fail, emergency uplock release systems allow the landing gear to free fall into position. In some aircraft, gravity and aerodynamic airflow alone are not sufficient to extend the landing gear. In these cases, manual extension systems are used. The pilot mechanically cranks or pumps the landing gear into position using a hand crank, extension handle, or mechanical linkage system. These systems provide a dependable backup method for extending the landing gear during hydraulic or electrical failures. Landing gear retraction systems combine mechanical, electrical, and hydraulic components to ensure safe aircraft operation. From simple manual systems in small aircraft to advanced hydraulic systems in large airliners, every component must operate in precise sequence for safe takeoffs and landings. Thanks for watching.